Okay, now we're tasked with finding the equation of the line normal to the function. And all that means is, let's say you have a cubic function, and then you find the equation of the tangent line. So this line right there, that line right there, that's the tangent line at this given x value. So let's say the x value is 1, right? Well, the normal line is just going to be the line perpendicular to the tangent line at that same given x value. So that's kind of the vocab behind it in the visual. That's what it's talking about. Okay, so some functions are easier than others. So the first task is you need to find the derivative function, because the derivative is how you find the slope of the tangent line. So keep in mind, our ultimate goal is to find m tangent. Then we're going to find perpendicular to the slope of the tangent line is the slope of the normal line. But what produces the tangent is the derivative function. All right. So this first function that we're given is a rational function. So in the denominator, we have the g function, and the numerator, we have f. So remember, that's a quotient rule. So the quotient rule says this: g times the derivative of f, so f prime, minus f times the derivative of g all over the g function squared. So here's our f, here's our g. Our f prime, well, the derivative of 1 is 0. G prime, the derivative of x squared subtract 4, well, the derivative of 4 is 0. So that will go away. But the derivative of x squared is just 2x. So now we have all the important pieces. We have f, we have g prime, and we have f prime, and we have the original formula. So dy dx is g times the derivative of f. That will go away because 0 times that thing. Subtract the f formula, the f function, which is 1, times the derivative of g. And then all of that is over g squared. Then we're going to simplify. Since 0 times the g function is 0, what we have left with is negative 2x over x squared minus 4. So this is the derivative function. This stuff right here is dy dx. Now, to find tangent, the slope of the tangent line, remember, the slope of the tangent line, you use the derivative at a given x value. So when we plug negative 3 into both of those x's, so negative 2 times negative 3 is 6, negative 3 squared is 9, 9 subtract 4 is 5, 5 squared is 25. So this right here, well, let me erase this. This is dy dx, and then where x is equal to negative 3, we just found m tangent. So if m tangent is 6 over 25, remember, m normal is perpendicular, so m normal will be the opposite. So this is positive 6 over 25, so negative, and then you do the reciprocal. And then it's still going to be at that exact same point. Well, this is our x, this is our y, this is our m normal. And now we use point slope formula. Remember, y minus y1 equals slope times x minus x1 from algebra 1. So y normal minus the y value is 1/5, equals m normal, slope of the normal line is -25/6, times x minus the x value. The x value is -3. So remember, this subtract a negative becomes +3. Then we're going to simplify. Do the distributive, -25/6 x. And then when you multiply that, the 3 and the 6 cancel, and you got -25/2. And then we're going to add that 1/5. These two need to have the same denominator, so we'll multiply top and bottom by 5, top and bottom by 2. So what you have is -25/6x. And then 5 times -125 is -125, and that'll be over 10. And then 2 times 1, that's +2/10. So then you have -123/10. This is the equation of the normal line. All right, now we're going to do one more. This one's going to be a bit easier because finding the derivative of a polynomial is pretty easy. That's a negative sign. This will become -3. And then remember the power rule. You take the exponent, subtract 1. Bring that number in front. So that becomes 6x to the first. And the derivative of a constant is 0. So this right here is our derivative function. And when we plug x is equal to 1 into those x's, that's what's going to give us m tangent. 1 squared is 1, -3 plus 6 is 3. So now we find m normal. It's the opposite reciprocal. So m normal -1/3. And we're going to use the points 1, 5, and we plug it into the point slope. So y subnormal, subtract the y value, which is 5, is equal to the slope of the normal line times x minus the given x value. So when we distribute that, then when we add 5, when we add 5 over here, we want the denominator of 3. So we'll just rewrite 5 as 15/3. Now these two things can be added together. So the final simplification for that, this is the equation of the line perpendicular to the tangent line, y normal. All right, that's it for this video.